name is Michelle Clue, and today I will be teaching you about weak acids, weak bases, and buffers and salts. So the first thing we need to do is establish what an acid is. So based on the Bronsted-Lowry definition, an acid is a molecule that donates a proton, which is an H plus, which we donate as an H plus, but it's also H3O plus, technically. And a base accepts an H plus ion. So weak acids are molecules that only partially ionize. When something ionizes, it means that it is breaking up into its little ions. So as an example, I showed here a weak acid, hydrofluoric acid, mixed with water, ionizes into fluorine, which is its conjugate base, and H3O plus or H plus. Now, in solution, here's the solution, it partially ionizes, which means that most of the time it stays as HF instead of splitting up into F minus and H plus. We say that F minus is a conjugate base because it has the potential to accept back an H plus and become HF again. So that's why we have the double arrows in the equation. So, now that that's established, we say that when both the weak acid and its conjugate base are present in the solution, we say that that solution is a buffer. A buffer has to contain a weak acid and its conjugate base, or a weak base and its conjugate acid in order to be effective. When both are in solution, the acid reacts with the base, and the base reacts with the acid. You can add in a conjugate base or acid through a salt, and a salt is usually a nonmetal covalently bonded to a metal or another type of ion. And so I have an example here. If you have these two molecules, can they be a buffer in an equimolar solution, which means that the moles of both ions or both molecules are exactly the same. So, first thing we need to do is we need to ionize each one to make sure that one is an acid and the other is a base in the solution, because one has to be a weak acid and there also has to be the conjugate base in order for it to be a buffer. So we split Na2SO3, and you get two Na plus ions and one SO3 2 minus ion. Then you split up H2SO3, which is a weak acid, into H plus and HSO3 minus. Now, H2SO3 is what we call a polyprotic acid. Polyprotic acid means poly, many, protic, meaning proton acid, meaning that when it ionizes, it can give off many protons at once, but only one at a time. So, we say that this solution is a buffer because this HSO3 minus is actually a weak acid, and SO3 2 minus is its conjugate base. HSO3 minus can lose that hydrogen to become SO3 2 minus, and that's why we say that this solution is a buffer.